Hi there. So today I'll be covering the final section of vocabulary terms for this matter unit. Take out your pens and notebooks and update any of the information in your notebooks as you need. Are you ready? Let's begin. The atomic number is the number that is used to tell you where an element is located on the periodic table. In fact, this is how the periodic table of elements are organized. The atomic number also indicates the number of protons, which have a positive charge, that are contained in the atom, more specifically the nucleus of the atom. The atomic mass, which is the second number that you would see on an element square, on a basic element square, tells you the average mass of the atom or element. It's also known as the atomic mass units, or AMUs. And the reason why I say it's the average is because most of the elements contain isotopes, which just means that there's a difference in the number of neutrons, but it does not change the element itself. So that's what I mean by isotopes. But the mass tells you basically how many protons and neutrons are contained in the nucleus of that atom. Typically, when you want to find the number of neutrons, all you have to do is take the rounded atomic mass and subtract the atomic number, and the number remaining is the number of neutrons in that element. A chemical bond is a force of attraction between two or more atoms as a result of the electrons. Electrons, depending on the type of bond, can either share electrons between the elements, or they will give or take electrons. There are three types of bonds. You have ionic bonds, covalent bonds, and metallic bonds. A chemical equation is simply a way to show and summarize a chemical reaction, but instead of using words, you're using symbols. You're using chemical symbols, you're using an arrow that means yield or produces, and you also have the plus sign for and or addition, etc. The numbers that you have, the chemical formulas that you have on the left side of the arrow would be your reactants, and the chemicals that you have on the right side of the arrow would be the product. So H2 plus O2 yields or produces H2O. Once we get started with looking at chemical equations, we'll start to identify when the equation isn't balanced, like in this particular case. And so we'll talk about that when we're looking at the law of conservation of matter, or the law of conservation of mass, but more on that later. So while this particular example is an example of a chemical equation, it's not balanced just yet. Chemical formula is a combination of symbols, which are the chemical symbols that you see on the periodic table, and it also shows the ratio of those elements in a compound. So here I have sodium, and since I have this subscript here, that's the number 2, it means that I have 2 sodium atoms. Here I have sulfur, and since there's no subscript here, I can automatically say that there's only 1 sulfur atom. And then oxygen has a subscript of 4, so it means I have 4 oxygen atoms in this chemical formula. The coefficient, which will again is another term that we'll use heavily when we're looking at the law of conservation of mass, is the number that you place in front of a chemical formula. So in this section here, right to the left of sodium, if we needed to balance, in this particular case, we would put a coefficient here to help us balance. We don't have a full equation to do anything, but know that a coefficient would be the larger number, and then the subscript is the smaller number. We have the chemical symbol. Every element has a chemical symbol. Some contain one letter, like oxygen. Others contain two letters, like nobelium. And other elements contain three letters. And the first letter in a chemical symbol is always capitalized. You don't want to capitalize the second letter, because then you could be implying, or not could be, but you would be implying that you have a different substance. So always make sure that only the first letter is capitalized and the remaining letters to the right of that first letter are lowercase. On the periodic table, it consists of rows and columns. Your columns are also known as groups, and you have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 groups. The groups are also known as families, and we'll talk a little bit more about the different types of families. And elements that are in the same group typically have the same chemical properties. So we'll take a look at that when we dive into this unit a little bit more. Then you have the law of conservation of matter, or mass, which I stated earlier, and it is the law basically states that mass or matter is neither created or destroyed, but can take on a new form. It can be changed. This is a particular example where we have a substance in one container and we add it to the substance in another container, and we have a chemical reaction that results in a new substance, but nothing was lost, nothing was gained. We have whatever we had to the left of the, in this case, the equal sign, but if we were writing a chemical equation, then it would be an arrow. So what we have on the left is the same amount that we have on the right. And we'll talk a little bit more about the different types of chemical reactions that you can have. The periodic table contains over 100 elements. As I said earlier, they're arranged by atomic number, and the elements in each group have similar properties. As you go across the rows, you'll see how they're unique from one element to the next. And these properties repeat as you go along. You'll see trends as you go from left to right to the next row, left to right, so forth and so on. Earlier we talked about groups, and those were the columns from top to bottom, and there are 18 of those. And then you have the rows. The rows are also known as periods, and we have 7. 1, 2, 3, 4, 5, 6, and the other part that's missing on here, we do have another part that's missing from this one. This is not exactly accurate, but there's 7 horizontal rows, and the properties of the elements change in a pattern. So we would see a consistent pattern as we go from left to right, and then to the next row we'll notice the similar pattern going across from left to right, so forth and so on. The valence electrons are your electrons in the outermost energy level, or they're the electrons that are the furthest away from the nucleus, and these electrons help to determine the properties of the atoms. We have a few examples of valence electrons and how they appear. We'll spend some time this year learning how to do the Lewis structure and how we use that to bond. We'll learn how to set up the Bohr's model so that we can also see the valence electrons in those diagrams. And this covers the vocabulary for the final section of the matter unit. Bye now.